On the Davis campus of the University of California, the Crocker Nuclear Laboratory, site of the Davis 76-inch isochronous cyclotron. The center of the cyclotron is its main magnet. Originally constructed for a 60-inch cyclotron by Dr. E.O. Lawrence at UC Berkeley in the late 1930s, the original laminated steel yoke was acquired by the Davis campus, and additional layers of steel plate were welded on. The pole tip was enlarged to 76-inch diameter, and shaped steel hills and variable magnet shaping coils were added to form the present 268-ton main magnet. The magnetic field is carefully shaped to hold the accelerating particles in their respective orbits. From an anchor point at the end of the resonator tank, the D is cantilevered 23 feet to the center line of the main magnet. Also at the center of the main magnet is the ion source, a hot cathode electron stripping device that produces the initial ionized particles for acceleration. Its 8-foot length is inserted vertically through a hole in the bottom of the main magnet. Accelerating power is delivered by an RCA 6949 power triode, a 140-pound vacuum tube that is used to deliver 30 to 140 kilowatts of radio frequency energy to the D structure. After many cycles of acceleration, the high-energy particles are deflected from their orbits and leave the cyclotron. The particles are magnetically focused and directed to a 40-inch diameter switching magnet which controls the amount of bend necessary to select one of the required beam lines. One of the beam lines connects to a lithium target, where high-energy protons produce high-energy neutrons. The residual charged particles are bent out of the main path magnetically, and the neutrons pass through a collimator into the South Cave experimental area. The cave has a very open structure to reduce neutron backscattering. Samples and detectors are placed in strategic locations during the experiment. Another line terminates in a chemical target. The Heart Chemistry Laboratory is used in checking and processing the results of these irradiations. Productions of fluorine-18 and I-123 are done routinely. The trace element analysis area in the North Cave uses an automatic changer in rapidly analyzing hundreds of samples. A new line is being prepared for a beam microprobe and to be used in trace element analysis and examination of historical artifacts. A 30-inch scattering chamber is available for charged particle experiments. Beyond the scattering chamber is space for large area beam irradiations. A compact irradiation area is available for material damage studies or simulated space irradiations. Power for the various magnets is brought in through a tunnel, along with control and signal cables, cooling water and vacuum lines. The major power supplies are located under the main vault. Most of them are moderately low voltage but precisely regulated high current sources. The low drift requirements are required to produce and maintain the beam exactly on target. The cyclotron is surrounded by shielding walls of concrete 10 feet thick. Normal access to the machine is through vertically operated hydraulic doors. For special maintenance or major changes in experimental equipment, the double layer of 54-foot-long roof blocks can be removed with an overhead 30-ton crane. Due to radiation produced by the cyclotron and distances between pieces of equipment, controls are gathered together in one place so the entire machine can be monitored and operated by one person. Magnet controls, radio frequency system, ion source, and beam extraction devices are precisely adjusted to deliver the required beam to the appropriate target. The signals resulting from beam irradiating targets and detectors are channeled into the counting room. Here signals can be conditioned and processed for immediate analysis or stored for examination at a later time. The electronics and computers can be configured for a wide variety of experiments. Due to the age and unique nature of the Davis cyclotron, many parts are manufactured and assembled in our own shops. Engineering and maintenance are continuous, always striving for improved reliability. The Davis 76-inch cyclotron, a versatile research tool. Thank you for visiting Crocker Nuclear Laboratory.